All right. All right. So we're here. We're doing the first one. We have log 7, 3x plus 12, and we're trying to find the domain. So remember, to find the domain of a logarithm, you got to take the inside. To find the domain of a logarithm, you take the inside and set it greater than 0. You take the inside and you set it greater than 0. So you have 3x plus 12 is greater than 0. Subtract 12, subtract 12. 3x is greater than negative 12. Divide by 3, divide by 3. You'll get x is greater than negative 4. Once you get it to this notation, you then just have to put it in interval notation. Interval notation will be negative 4 to infinity. Notice that we're putting a parenthesis. Notice that we're putting a parenthesis on the negative 4 and not a bracket. It is strictly greater than, not equal to. I'll monitor the live feed. Looks like most all of you have a microphone, so you can just unmute yourself and have a question if you want to. Or I'll monitor the live feed and you can type it in. All right, going once, going twice.
What does the 7 do in log 7? It doesn't do anything then?
No. No, it's no. You can always ignore the base. All right, ln of 4 minus 6x. We got y equals the ln of 4 minus 6x. We take the 4 minus 6x, we set it greater than 0. We get negative 6x is greater than negative 4. Divide by negative 6, divide by negative 6. X is going to have to rotate that inequality now. Going to have to rotate that inequality because you divided by a negative. This is x is less than 2/3. So we're going to say negative infinity to 2/3. Questions on that? Questions on that? Questions on that? Anybody? Now we got log x squared minus x minus 2. I think we have a 2 out front. I think it looked like that. Okay. How do you do this kind of problem? Well, again, you're taking that inside part and you're setting it greater than 0. You're taking that inside part, you're setting it greater than 0. You're factoring this to x minus 2, x plus 1 is greater than 0. And then when you get a quadratic, if you have a quadratic, x squared, or if you have a fraction where you have something over something, both of these, you do a sign graph. X is 2, x is negative 1, and then you're plugging in numbers on all sides. All right? You're plugging in a number like, for example, negative 4. And you're saying negative 4 minus 2, negative 4 plus 1. This one's a negative number, this one's a negative number. So when you multiply those together, the result is a positive number. Then you're taking a number between negative 1 and 2, say 0. And you're doing 0 minus 2, 0 plus 1. And you're recognizing that 0 minus 2 is a negative number, 0 plus 1 is a positive number. And if you multiply those together, that will collectively give you a negative number. So plugging in 0, we get a negative number. All right. Then you're going to plug in a number to the right of 2. Call it 6. And you're going to plug that in. 6 minus 2, 6 plus 1. you're going to realize that the 6 minus 2 is positive, the 6 plus 1 is positive, and when you multiply those together, you get a positive. Okay? So when's it greater than 0? It is greater than 0 here and here. Okay? And that will give you a final answer of negative infinity to negative 1 union 6 to infinity. All right. Yeah, my bad. My bad. Yeah. Thank you, Ashley. Thank you, Philip. Any questions? Any questions? All right. All right. So we go here. We go log base A 8 equals 4.2. Log base A 6 equals 3.8. We want to find log A of 2, log A of 48, log A of 36. Let's try those three. All right, Dino, Anna, Savannah. Talk to me. Carly, what class are you in, baby? Okay. All right, y'all ready? Dino, you ready? Savannah, you ready? Anna, you ready? All right, let's do this. Assuming everybody from college algebra's got the problem written down, and still nobody from intermediate, right? All right. Before I go full screen on this, let me bring up the calculator. All right, because we got to find the mean and the standard deviation. We're going to put it on top of their problem. Stat, edit, L1, clear, get out of there. 1.65 plus JK. 1.7 1.83 1.62, 1.81, 1.74. Stat, calc, one variable statistics. And we're going to paste it right here. All right. So now, and you're going to have a problem like this, okay? So, let's just be very clear about that. You're going to have a problem like this. And I need the T-score chart. All right. We need a T-score chart. Um, so part A is draw a picture. Part A is draw a picture. This inside part is 0.95. Makes the outside part 0.025. We got to go to our T-score chart, which is going to require us to use degrees of freedom as n minus 1. What was our n? Our n is 6. So if n is 6, degrees of freedom is 5. So that puts us in this column. It puts us here. The area in one tail is 0.025. This one. So we're going to go down 0.025 over to 5, and we're going to get 2.571. All right. We're going to get 2.571. All right. Part B. Give me a second, please. All right. So then obviously the other side is negative 2.571. Part B is knowing the formula. Formula is x bar minus e is less than mu, which is less than x bar plus e, where e is equal to t times s over the square root of n. Now, I'm going to go ahead and jump to the next slide We're going to use 1.73 minus 2.571. 2.571 times 0.08 divided by the square root of 6 is less than mu, which is less than 1.73 plus 2.571 times 0.08 over the square root of 6. All right. So far, so good. Dino, Savannah, Anna, we good? You guys have questions? We're using S. So, Savannah, very, very important point here. And I know it's confusing because in class we kind of pick and choose. You'll always use S. You'll always use S. You'll always use S if you have to find it yourself. The only time you would use sigma is unless I explicitly say sigma equals 0.07. Does that make sense? I mean, I would give you this in the problem. You'll never find it on your own. The only one you ever find on your own is S. All right. And I know it's confusing because in class sometimes I'll say we're going to use sigma, but that's just because I want to do a problem where we know sigma. But on the test, it's never that way. All right. So let's bring up the calculator. We got 1.73 minus 1.73 minus 2.571 times 0.08 divided by square root of 6. All right. That's the left side. Now doing the same thing, but changing the minus sign to the plus sign. Oh, shoot. Changing the minus sign to a plus sign. That will give you that'll give you your two values. Again, if this is 2 decimal places, we generally will go 3 decimal places here. So we'll go to 1.646 less than mu, which is less than 1.84. All right. This is part C. This is part C. Part D. Part D. Do I need to interpret, or do y'all know how to do that? If we continue to take samples of size 6, we expect... Dina, were you typing? Okay. No, not for that one, no. We expect... If you do, though, Dino, it doesn't matter. If we continue to take samples of size 6, we expect 95% of the sample means to be between 1.646 and 1.814. Part population is normally distributed, and sigma is unknown. Nice spelling there, genius. All right. As it relates to this, I do want to show you one other thing. If you go to stat, test, and you go down to option number 8, that is T interval. Option number 8 is T interval. Z interval is if you knew sigma. T interval is if you're doing a T-score. I'll be on stats. I'll say that the X bar is 1.73. I'll say that S is 0.08. And we're doing a 95% confidence interval. And then we calculate it. I don't know, Dino. Don't know what to tell you, my man. But there you go, 1.646 and 1.814. Okay. So, hey, Dino, you got my number, right? Text me. Take a screenshot of what you got. I'm sure it's just a typing it in issue. All right. So now let's go back to the same problem, and let's go problem number 2. Let's test the claim that the average is more than $1.60. Or $1.65. Let's test the claim that the average is more than $1.65. Use a 0.05 level of significance. All right. Let's go number 2. And let's test the claim that the average is more than $1.65. All right. All right, college algebra, y'all ready? Okay, good, Dino. All right, Philip, good. Philip, do you have the first one?
Yes, sir. I have all of them.
All right, what'd you get for the first one?
I got 1.4.
Yes. Dino, test the claim that the average is more than $1.65. Test the claim that the average is more than $1.65. All right. So how do we do log A2? You're looking at these two numbers, and you're trying to get 2 written as either 8 raised to a power, 6 raised to a power, or some function of 8 times 6 or 8 divided by 6. Okay? Those are pretty much the only things you can do. All right? Those are pretty much the only things you can do. You either got to get 2 equals 8 to a power, 2 equals 6 to a power, or some function of 8 and 6 that are multiplication division. A lot of people will make the mistake and say 8 minus 6 is 2. Yay, I got it. No, if you get it to a plus and minus, that doesn't do you any good. All right, you might as well just pick a random number then. Okay. No, it cannot be 2.1. You divide it by 2, and divide it by 2 is the square root of 8. So what you have to recognize is that 2 is 8 to the 1/3 power. 2 is the cube root of 8. Two is the cube root of 8. All right. So when you do this, you say that this is equal to log A 8 to the 1/3. Then the 1/3 will drop out front. And then you'll get 1/3 of 4.2, which is equal to 1.4. Okay. Ashley, do you see how that works? All right. You're good, baby. Now, how do you get log 48? Well, again, as we look at this, you got to look at 48 and say, how do I get 48? I have 8 and 6. It's got to either be 8 to a power, 6 to a power, 8 with some power times 6 to some power, or 8 to some power divided by 6 to some power, or the other way around, 6 to some power divided by 8 to some power. Does that make sense? I mean, it could be that way too. And in this case, 48 is simply 8 times 6. So we say that log 48 is log 8 times 6, which means it's log 8 plus log 6. And you would add those together. So it would be 4.2 plus 3.8, and you'll get 8. Any questions on that? Any questions on that? Ashley, we good? Philip, we're good? Gavin, we're good? Carly, we good, baby?
Yes, sir.
All right. Who else we got in here? Am I missing anybody? Richard, we good, baby?
Yes, sir.
Oh, shit. Maybe I should have recorded it. My bad.
Probably.
You know what? To all you who are joining us right now on the recording, that was my fault. It was my fault. And I'm not going to lie. It may have had something to do with Richard. I mean, it could have been something to do with Richard. Not going to confirm nor deny.
Hey, man, don't blame this on me. Come on, man.
You know, I love you, Richard. Anyway, any questions on this? All right. Now, log A 36. Log A 36. Hopefully, it's starting to get a little bit easier. Log A 36 is log A 6 squared. The 2 is going to jump out front. And you're going to get 2 log A 6. And once you do that, you're going to get 2 times 3.8, which is 7.6. All right. Dino, what's up, baby? Yes. Yeah, Dino, you're using the same ones. All right. College algebra, any questions? Richard, Gavin, Ashley, Carly. All right, let's do it. Let's go to the next one. Let me give you, let's go log 7, 3x minus 5 equals 1. Let's go log 4. Let's go log 4, 2x plus 6 equals negative 2. And then let's go ln 3x minus 2 equals 5. Let's solve these. Let's solve these. All right. Everybody got them written down? Jan's got them. Gavin, you got them. Carly, you got them written down. Ashley, you got them written down. Richard, you good? Julio, I know you're watching this on YouTube, but you're a little bit delayed on me, so but you can press pause, Richard or Julio. Maybe he's not watching this. It's all right. It's all right. All right, here we go. Dino, we're back to you, baby. Savannah, I'm coming for you. Let's take a look. So we're testing the claim that the average is more than $1.65. All right. So our claim is that the average is more than $1.65. Now, here's the thing. You got to know whether or not this is going to be written in as the HO or whether or not this is going to be written in as H1. Okay? You got to know whether or not it's going to be written in as HO or whether it's going to be written in as H1. Okay? Anna, tell me how I know. Anna, can you take yourself off mute for a second? Oh. Savannah, can you take yourself off mute for a second?
Yes, what's up?
How do I know whether or not that claim, after I write it like that, how do I know whether it's going to be HO or H1? Because the test starts today, baby. We got to figure it out.
HO is when it equals
Okay,
that
so
number.
HO will always have an equal sign in it.
Yeah, and then H1 is when it has the greater or less than sign. In this case, it's greater.
Okay, so we would know that this has got to be written in as H1.
Yes.
Okay. Anna, did you know that? Good. So, so HO is that mu equals 1.65, and H1 is that mu is greater than 1.65. So this is part A. Part B. Part B. Now, part B. Savannah, are you still there?
Yes, sir.
Now, how do I know if it's left tail, right tail, or two tail?
By the way, the sign is pointing, so this one is right tail.
Good. Did you missed a couple classes there?
I didn't know. I was late to one class.
Oh, okay. All right. So this area is 0.05. Hey, Dino, take me off mute for a second, Dino. Savannah says she's tired of doing all the work. Maybe Savannah, you might be the only person who can talk. Yeah, Savannah, it's just you and I, baby.
Oh no.
Dino and Anna. Well, yeah. And here's the deal, Savannah. You just got to get better at lying, right? See, Dino is just like, oh, I really can't. He actually can. Like, he can put his headphones in and talk to us, but he's choosing not to.
Yeah.
Kind of like I could choose not to have ice cream at night, but that's not happening.
All right? Yeah, me too.
When you looked up the 0.05 on the one-tail test, what did you get?
2.015.
2.015?
Yes.
Anna and Dino, we got those? All right, Savannah. If Anna says yes, then you're good, and that's just you're golden right there. All right.
Okay.
Got another formula: T equals x bar minus mu over s divided by the square root of n. Part D, T equals 1.73 minus 1.65 divided by 0.08 divided by the square root of 6. Is that right?
Yes.
Get out of town. So in this case, T is equal to 2.48.
That's not the number I got.
Well, honey, I'm probably wrong. I looked up here and I saw that 1.73 minus 1.65 was 0.08. And that 0.08 and the other 0.08 we're going to cancel, and you're just going to get whatever the square root of 6 is. And so I was just estimating the square root of 6 is 2.48, but I don't know what the hell the square root of 6 is.
Okay, well, I think it might be because of the parentheses. I used parentheses because I got 0.41.
Oh, yeah, one of us is wrong. And I hate to tell you this, Savannah, but I'm going to say it's you.
Yeah, probably.
I mean, let's just be honest.
No, yeah, you're right.
1.73, we're going to type it in just like this. 1.73 minus 1.65. Now, where you run into problems, Savannah, and I don't know what you did, but I'm guessing I know what you did. My guess is that you went like this. Divide by 0.08. Divide by square root of 6. Whenever you do that, you almost always get a really small number.
Okay.
There you go. All right. The way you got to type it in is that bottom piece has got to be in parentheses.
Okay.
All right. And sometimes, Savannah, you don't learn the stove is hot until you touch it. You know what I'm saying? All right. My bad. 2.45.
It's confusing. I don't ever know when to use the parentheses.
Yeah, it is. It's very confusing. As a general rule, I'll help you with this. For confidence intervals, you can usually just type it straight. All right, you really don't need to use parentheses on confidence intervals. For hypothesis testing, it's parentheses on the top, divide by parentheses on the bottom.
Okay. That's what I normally do. Like, in general is what I do.
Yeah.
So I guess where I run into problems.
No, it is very confusing. Because, like, I've seen people who do the hypothesis test 1.73 minus 2.571, and then they put that in parentheses. And that'll mess it up, too. Okay.
Yeah.
So, generally, with the confidence interval, just type it in straight. Don't use any parentheses at all. And then, but under the square root, make sure you're using the times symbol and the division symbol. Okay. Don't use parentheses under a square root. It'll really mess you up.
Okay.
All right. Let me get rid of this. Now, what does that mean to E? So do we Savannah, where is 2.45? Is it in area A, B, or C?
C.
It's in area C. So this is 0. 2.4 is to the right of 2.0. So you will reject HO. All right. Now, if you reject HO, you're saying that this is false and this is true. And so you would say at a 0.05 level of significance, there is sufficient evidence to support the claim that mu is greater than 1.65. All right.
So it's reject HO because it's in the shaded area?
Yes. It's reject HO because it's in the shaded area.
Okay.
Population is normally distributed, and sigma is unknown. This says unknown, and you can't read that for nobody's business. Any questions on that? Anna, Dino, we good? Anna, Dino, we good? No, I didn't. You're Anna. I love you. I just want the world to know that I love Anna. Okay. Dino, I'm a little bit peeved at because Dino's choosing not to join us in the chat, and that's why you got forgot, Dino. I'm just saying, Dino, you got the technology resources to join us and talk to us. But nah, you're like, oh, I want to be quiet. But I still love you, and I'll still buy you Chick-fil-A when I see you. Is there anything else? Yes, Dino, there's a lot of shit on the test. What the heck kind of question is that? How about this question, Dino? How about this question? In a recent study of cable bills, 45 bills were randomly selected. The average cost is $185. Sigma is $32. Construct a 98% confidence interval for the mean. Dino, did I finish the practice test? No, man. I gave up on that. I mean, I don't want you to be mad at me, but I did get 4 problems done, though. What you got, Savannah? And love you, Savannah. All right, y'all got the problem written down? Savannah, you're good. Anna, you're good. Dino, you're good. There's no P for this one. This is mean. Dino, for real, we only use P when I say like 18 out of 30. That's when we use P. If we're talking about the average, we don't use P. A PU? Where the hell is PU? I don't know. I'm sure you can find a PU somewhere in there. That's confidence interval. 98% confidence interval. Oh, no, that's X bar. That's X bar. That's X bar equals 185. All right, here we go. College algebra. Here we go. So we're solving these. Now, the secret to solving logs. The secret to solving logs is convert them to exponentials. Okay? Is to convert them to exponentials. Now, the first one hopefully isn't that bad. You got log base 7, 3x minus 5 equals 1. All right. That's 7 to the first equals 3x minus 5. 7 is equal to 3x minus 5. We're going to add 5, add 5. 12 is equal to 3x. We're going to divide by 3, divide by 3. We're going to get x is equal to 4. Okay. So that one hopefully isn't too bad. Any questions on that? Questions on that? Carly, we good? Philip, we're good? Ashley, we're good?
Yes, sir, we're good. Yeah, I just have a question. So you just plug the number from the log like under 1, or how did you do the first step?
Yeah, so I changed it from a logarithm to an exponential. Remember that to change it to an exponential, we drop off the log and then we swap these two sides. So that becomes 7 to the first equals 3x minus 5.
Is it always to the power of 1 or no?
No, I mean the next one's not to the power of 1.
So if there will be equals 2, it will be 7 power of 2 or no?
Yep.
All right.
So let's look at the next one. We got log 4, 2x plus 6 equals negative 2. So here you go, Jan. We're going to drop off the log. We're going to swap these two. So this is going to become 4 to the negative 2 equals 2x plus 6. Okay. This 4 to the negative 2 becomes 1 over 16 equals 2x plus 6. Now, how you solve this is kind of your personal preference. What I do, and this is strictly what I do, I multiply everything by 16 to clear the fraction. That's my personal choice. Okay. So this 16 and 16 cancel. And we'll get 1 equals 32x plus 96. We'll subtract 96, subtract 96. We'll get negative 95 equals 32x. We'll divide by 32. We'll divide by 32. And we'll get x equals negative 95 over 32. Okay. Uh, 95 breaks down to 5 times 19. 5 and 19 are both prime, so that does not reduce. Okay. All right. Any questions on that? Any questions? And again, you don't have to do it that way. You could subtract 6 and do 1/16 minus 6 and then divide that by 2. That's a totally okay way to do it as well. Okay. Now this one's a little different. ln 3x minus 2 equals 5. Is that right? Now, this one's a lot harder because where the other two, the bases were given, when they're not given, you have to know what the implied base is. Philip? So,
Mr. Dryer,
yes.
I think you accidentally stopped screen sharing. I can't see you anymore.
Oh, my bad. All right. Is that better, Gavin?
Yes, sir.
All right. That's some bitch. So the implied base for the ln is e. The implied base for the log is base 10. So you got to know both of those. Okay, they're going to get used on the test, I promise. All right. So this is e. So now how do you take this and convert it to an exponential? You drop off the log, and then you swap these two around. So e to the 5th equals 3x minus 2. Now, we're not going to deal with e to the 5th. We could go to our calculator and type that in, but we're not going to. We're going to add 2, add 2. We're going to get e to the 5th plus 2 is equal to 3x. And then we're going to divide by 3, and we're going to get the final answer of x equals e to the 5th plus 2 over 3.
I have the question.
Yeah, please.
So, what's that 10 for? Like,
So if I gave you a problem that said solve this. All right. And you had to solve that for x. You got to know, Philip, that this is a 10. So that when you go to switch this from out from a logarithm and put it as an exponential, it's 10 raised to the second equals x plus 4. All right. Because all the problems we did up to this point has had a number here. You see what I'm saying?
so if there's log without the number, we put 10, but if there's ln without the number, we put e, right?
Right. And now understand that you cannot have ln6. Like that you can't have that. That's an oxymoron. The only thing you can have for ln is e. That's the only letter that's allowed to go there.
All right.
Nothing else can go there. If you want to put a number there, then you got to switch it from ln to log. All right.
Yes, sir.
All right. We're going to give you these last two to try. We're going to go 8 to the 3x plus 5 equals 1/16. And then we're going to go 4 2x plus 7 equals 9. Let's try those two. All right. Do those. Anna, Dino, Savannah, I'm coming to you. Ashley, we're doing circles next week. We're not doing circles right now. All right, Dino, here we go. Come on, Savannah. We'll figure it out. Here we go. Capabilities use construct 98% confidence interval. You don't need parentheses for this one. So, part A is draw a picture. This area is 0.98. This area is 0.01. That makes this value 2.33. That was the option you want. Oh, yeah. Okay. Part B. Part B. X bar minus E is less than mu, which is less than X bar plus E, where E is equal to Z times sigma over the square root of N. Yeah. Part C, 185 minus 2.33 times 32 over the square root of 45 is less than mu, which is less than 185 plus 2.33 times 32 over the square root of 45. Okay. We go to our calculator and we type it in. $185 minus 2.33 times 32 divided by the square root of 45. Now we'll do the same thing, but change it to a plus sign. Okay. All right. So now we have 173.9, 173.9 less than mu, which is less than 196.1. And I want to be honest here. Dino, can you hear me okay? Dino, you good? Anna, you okay? You can hear me okay? Here's the deal. If you have this problem on the test, and you know the test is multiple choice, right? And the problem says construct a 98% confidence interval. And then it gives you a series of answers. And all it is a bunch of damn confidence intervals. Like 173.9, whatever it is, right? 165.4. If it's just asking you for the confidence interval and it's just giving you these choices, which are all set up as a confidence interval, then let's just be honest. All you really got to do, if we're being truthful about the situation, all you really don't even have to do A, B, C. You damn sure don't have to do D and E, right? Dino, you see what I'm saying? You don't have to do D and E because I didn't ask you for D and E. So there's no reason for you to continue and write down the interpretation when all it asked you was for the damn answer to start with. And secondly, and even more importantly, if it just asks you for this, Savannah, I'm not going to be mad at you if you just do this. And you go to option number 7 and you type in your numbers. Sigma's 32. The mean is 185.
Wait, what are the steps for that? Like the testing it?
You go to stat, you go over the test, and then you go to test, and then you're going to either a Z interval or a T interval, depending on which one you're doing. If you're doing the Z score, you do the Z interval. If you're doing a T score, you do T interval. And make sure that when you do this, that you're on stats, not data. If you're on data, it won't look right. It'll look like this. Okay, and it has the list in there. You don't want that. You want stats where you type in your own numbers. Okay. And then N is 45. Now, this won't give it to you necessarily exactly, but it'll get you so damn close that you're right. Wait, there's a problem there. That's a real problem there. Oh, no. You know why it's a problem? Because your dumb instructor said 95% confidence interval. We need 98%. And this is my point. We ought to get pretty damn close. Does everybody see what I'm saying? I mean, it ought to be pretty close. Okay. Does that make sense? Dina, we good? Anna, we're good? Okay, good. 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 All right, now, how do you interpret? How do you interpret? If we continue to take samples of size 45, we expect 98% of the sample means to be between 173.9 173.9 and 196.1. Part E. Whoa, just kidding. Just kidding. Since N is greater than 30, the sample mean is normally distributed. All right. Questions on that? Questions, comments, concerns? Anything? All right. All right. So look, stats guys, I'm going to leave you guys there. Unless you got something specific you want to ask. It's just hypothesis test and confidence intervals, The only other thing that's on there is, we could do a hypothesis test for this problem, right? This was the confidence interval. We could test the claim that the average is less than 190. And then you got a hypothesis test for the proportions, and that's it. Definitions are on this test, by the way, which shouldn't be that bad because, you would have to be able to do the p-hat for hypothesis test, Anna. But there are definitions. I did go ahead and add some definitions to this one. Could we do one of those, what? One of the p-hats? Yeah. So, in a survey, um, 85 out of 100 thought it was too soon to reopen the state. I just saw yesterday. That 72% of the people think it's too soon and they should extend it for another month. And I was like, y'all crazy as hell. But you know what? Who am I? Let's test the claim. Let's test the claim that it is that the proportion is more than 72%. Use a 0.02 level of significance. All right. Okay. All right. Jan, we ready? Carly, we ready? Gavin, we ready? Ashley, we ready? Richard, we ready? All right, let's do it. All right. All right. So how do we do these? So first of all, let's look at the difference between the two problems because they're both going to say solve. They're both going to say solve, but the way the answer is going to be presented is going to be entirely different. And here's the way it works. Okay. To solve this one, you're going to get the bases to be the same. To solve this one, you're going to use logarithms. All right. And the reason why is because for this one, where you have 8 to the 3x plus 5 equals 1 over 16, you can say that 8 is 2 to the third And you can say that 1/16 is 2 to the negative 4. All right. And now, because you got both bases to be 2, you can go ahead and set the exponents equal to each other. 9x plus 15 equals negative 4. Subtract 15, subtract 15. 9x is equal to negative 19. Divide by 9, divide by 9. X is equal to negative 19 over 9. Let me pause there for station identification. We good? Jan, we good?
Yes, sir.
Gavin, we good? Richard, we good?
Yes, sir.
Hey, Richard, where the hell did you go? Richard, MIA. All right, Richard, love you, man. All right, now, how do we do the last one? We got 4 2x plus 7 equals 9. What do we do for that? Now, because 9 is 3 squared and 4 is 2 to the second, there's no getting these bases to be the same. Like, there's nothing you can do there. So at that point, the only thing you can do is invoke the log of both sides. And you may think to yourself, well, what good does that do? It actually does a great deal of good. What that does is it takes the 2x plus 7 and allows you to move it out front as an exponent. And so that this becomes 2x plus 7 log 4 equals log 9. Okay. Now, how do you solve that for x? Distribute 2x log 4 plus 7 log 4 equals log 9. I'm solving for x. I'm solving for x. And I get 2x log 4 equals log 9 minus 7 log 4. To solve for x, I'll divide by 2 log 4. And this will be my final answer. My final answer is log 9 minus 7 log 4 over 2 log 4. All right. Questions on that?
Is it going to be on a test?
Yes. 100%. This test might be really long. Other questions? Other questions?
I have a question. So we cannot like put the final answer into like a simpler number. We cannot solve it out even more,
No.
right?
No, you would have to leave it like that, or some function thereof. All right. All right, college algebra. I'm going to leave you guys with that. I'm going to tell you thank you for logging on this morning. I know it was early. I know it was a yucky, rainy day, so I do appreciate you coming on. I will post these to the to both classes. So appreciate you guys logging on, and I'll see you whenever I see you for the next class. All right. Any questions? Any questions? All right, Richard, Ashley. No, I did not go this morning. It was raining. I said, screw that crap. Richard, Ashley, I'll see you guys later on. Statistics, let's do this. So first thing you got to do is figure out what p hat is. P hat is equal to 85 over 100, which is 0.85. You're testing the claim that the proportion is more than 72%. So part A, the claim in symbols is that P is greater than 0.72. So HO is that P is greater than 0.72. H1, just kidding. Whoa, I jacked that all to hell. H1 is that P is greater than 0.72. All right. Dina, we good? Anna, we good? Savannah? Part B. This is a right tail test where this area is 0.02. That value is 2.05. You're finding it on the Z-score chart. What do you mean you didn't start right? What does that mean? Oh. Yeah, if it's a hypothesis test, baby, this is where you have to do it. Part C. Z equals P hat minus P over the square root of PQ over N. Part D. Z equals 0.85 minus 0.72 over the square root of 0.72 times 0.28 over 100. All right, so we go to our calculator. We do 0.85 minus 0.72. But remember, that's got to be in parentheses. Divided by the square root of 0.72 times 0.28 divided by 100. This is what I was saying, y'all, that under the square root, use the time symbol and the division symbol. Don't use parentheses. If you use parentheses, people almost always jack it up. So this value is 2.89. Now, 2.89 is in the shaded area. All right. So you will reject HO. Part F at a 0.02 level of significance. There is sufficient evidence to support the claim. To support the claim that P is greater than 0.72. Part G, since N times P and N times Q are greater than or equal to 5, the sample proportion is normally distributed. All right. Questions on that? Oh, no. It's easy to do, especially if you use parentheses under the square root. That's the number one thing I see. So the two things I see generally are people who do it like this, 0.85 minus 0.72 divide, and then they go like this, square root, and they do 0.72 times 0.28, and then they divide by 100 like this. This screws it all to hell. All right, if you do it like that, that'll give you a really screwed up answer. Okay, well that's not bad at all. Yeah, that one will really screw it up. The other thing I see a lot of is this. I'll see a lot of people who have the bottom part right, but they don't. I see this quite a bit too. They do it like this, and then they get an answer that doesn't make any sense. Okay, so those are the two things I generally see the most. All right, any questions? Yeah. No problem. There may be a practice test under the files on campus, but that I don't even know for sure. You'd have to go to Canvas and look. I don't know that for sure. Do you know? There may be some kind of test for review on there. I don't know. All right. Any questions? You're welcome, Savannah. You're welcome, Dino. Hey, guys, thanks for coming on. I mean, I know it's early and it's a rainy day and it's real easy to want to stay in bed, but I appreciate you guys coming on. All right. Hey, make sure you take test 4 sometime between today. It's going to open in an hour and 40 minutes. It'll open up at 12 o'clock, Dino. All right. So it'll open up at 12 and 20 questions, all multiple choice. Hopefully it's not too bad. All right. All right. Anything else? All right, Savannah, Anna, Dino, you guys take care. Richard, I ain't mad at you for starting the damn chat and then leaving. But you can be off in 3, 2, 1. Peace out.